Now look at rational exponents. So in this case, you must remember that when we have a root, or in this case, a nth root, then we can rewrite it as a to the power of 1 over n. This is just a convention. And in this case, n is greater or equal to 2. It doesn't make sense to have n less than 2 because square root of 2, a square root, we write it like that, and we don't write a 2, we just assume that there's a 2 there. So we don't write a 2, we just write square root like that. And that's why I said we start at 2, and then for integers we have this convention. So it's something that you have to remember, and it will help you to do calculations if you know that the nth root of a is equal to a to the 1 over n. So for instance, if I have the cube root of 27. So what I want to do is I want to write that as 27 to the power of 1/3. But what does it help me? Well, we know that 27 is 3 to the power of 3 because it's 9 times 3, which is 27. And that is to the power of that. But we know we have a law. A to the m to the power of n is equal to we have the rule a to the m to the power of n is equal to a to the power of mn. So now we're going to apply that rule. And if we apply the rule, we get 3 to the power of 3 times a third, which is just 1. So that gives me an answer of 3. So it really helps us simplifying some of our expressions. You have to know that if I have, for instance, square root of 16 plus 9, that is equal to the square root of 25, which is equal to 5 squared to the power of a half, which is equal to 5, which is not equal to square root of 16 plus square root of 9. Remember, this square root is like a bracket, so this 16 plus 19 must be added first, that plus. We cannot apply this rule if it's not multiplication inside the square root of inside the nth root. Very, very important.